So hello everyone, I Raghavendra Singh welcomes you all in this channel. So today date is 29th of March 2025 and today we are going to discuss subject that will be basic electrical engineering. You all will be familiar of class 12 physics. In that physics, I think in first part of book we studied about Kirchhoff law and what are the elements and what about AC circuits, phase, waveform. These all we have already studied in our 12th class. So basically, what are we going to do here is I'll pick up some topic from this unit. I will be doing discuss module 1 and module 2. So module 1 is basic electrical engineering. Okay, so this is all about module 1. So let's discuss about the concept. So first topic, as I can see given, is types of electrical elements. Types of electrical elements. And you all know that what can be types of electrical element: active element, passive element, and unilateral element, bilateral element. There are so many elements which comes under electrical elements. So let's see on Google, because I have decided one thing, that I will be delivering a best content whatever I can do. So I have told you from my side that what is basic electrical element. Now search on Google what he will answer. So let's search what is electrical what is electrical elements engineering. Why I prefer to write after this BTech engineering, so that it gives a accurate answer and related to topics. That's why I used to write it. So as you can see, the fundamental components of the concept used in the design, analysis and operation of the electrical system, including circuit, network and devices. Here are detailed explanation. What are the electrical elements? Electrical elements are the conceptual abstractions, representation, idealized electrical components. They are fundamental building blocks, electrical circuits and all. And under this is resistor, capacitance, capacitor, inductors, diodes, transistor, ICs, that is integrated circuits. So that's all about electrical elements. Okay, now let's move on to the next question. So now we will discuss Kirchhoff law. Okay, so as we all familiar with this Kirchhoff law, Kirchhoff is the name of physicist, I think. So he gives basically two rules about voltage law. So what he said, first rule was sum of the, not sum, algebraic sum, algebraic sum of algebraic sum of the incoming current, incoming current is equal to outgoing current is equal to outgoing current. So basically, suppose example, this is something like this, here. Suppose here is coming 2 ampere plus 3 ampere. So here will be 5 ampere. So there is something about which Kirchhoff tells us. So yeah. And now what was second rule? Second rule was, what was second rule? Kirchhoff says in second rule that sum of the potential difference, sum of the potential difference, sum of the potential difference, that is voltage, in bracket we can write it, around any closed loop, around any closed loop. You understand what do I mean by closed loop? Means it's completely closed, not any circuit is open. Closed loop is zero. Closed loop is zero. So basically summation of I is equal to 1 and Vi is equal to 0. This is what Kirchhoff says in second rule. Yeah, so suppose we have example, and the resistance of 2 ohm, the resistance of 3 ohm. This is battery of 10 volt, and the current is going through this. This is 2 ohm, this is 3 ohm, this is 10 volt, this is negative, this is positive. We know that this is a sign of battery, or we can say capacitor. So we have to find here current. So as you can see that this is in series, this is in series, so we can write it 3 plus 2 5, and we know Ohm's law, V is equal to IR. So I is equal to V upon R, and voltage is 10 and resistance is 5. So I is equal to 2 ampere. Okay, so now we will discuss about on nodal analysis and mesh analysis. Oh, before this, let's search on Google. What will be according to Google, that will be more accurate. So let's search Kirchhoff law. Okay, so according to this AI overview, so in Kirchhoff law explained, Kirchhoff current law, that was first look. Kirchhoff KCL, we say this. Kirchhoff KCL, and Kirchhoff voltage law. As I told you that in this, which I told you in this which I told you that voltage. This second law is for voltage, and this is for current. Okay, so let's again see this. So basically, this law states that the sum of the current entering a node or in a circuit equals to the sum of the current leaving that node. In the simpler term, current flowing into a point must equal to the current flowing out to the point, reflecting the principle of charge conservation. Okay, charge conservation. Charge conservation. So mathematical representation, we can represent something like this. I hope you will be able to see. And second law is KVL. Second law is KVL, that is Kirchhoff voltage law. It states that this law states that the sum of the all voltage drops or potential difference around any closed loop in the circuit equals to 0. Okay, which I said. This is consequence of energy conservation, meaning the total voltage around the closed loop must be 0. Got it? And this is something how we represent mathematically. That is summation of V is equal to 0, and sign convention, voltage rises are considered positive and voltage drops are considered negative. Suppose we have, so voltage rises, suppose volt is rising here 25 to 30, so we will consider as a positive, and if decreasing then we will consider as negative. So this is all about KVL and KCL. These are some applications: circuit analysis, mesh and nodal analysis, DC and AC circuits, troubleshooting, design. This all. Okay, so now let's move on to the mesh and nodal analysis. So basically, now we will discuss about nodal analysis and mesh analysis. Okay, so what is node? First of all, node, where the branches meets, where two or more than two branches meets, that is called nodal. That is called node. Okay, suppose we have circuit something like this: R2, R3, and this is battery, negative, this is R1, R2, R3, E2, and this is again battery, E1, positive, negative, R1, R2, R3, R4, R5, R4, there is R5, if there is 4 resistance, then 4 will be also flowing current: I1, I2, I3, I4, I5. So basically how question can ask in nodal analysis that find VA and find VB, and this is here we have done earthing. There was something how question can be asked. So what we do basically in this we apply KCL, Kirchhoff current law. We apply simply Kirchhoff current law. What it says, like we will simply write a question. There will be two equations, two unknown, or three equations, three unknown. So we can easily find by solving the equation. Like here is, so here we can write RE plus R1 upon this current, that is R4. There was something how we solve the nodal analysis. Now let's discuss about mesh analysis. Mesh analysis. Mesh analysis. So suppose we have two resistance this is 10 ohm, this is 3 ohm, this is 2 ohm, this is 6 ohm, and this is 1 ohm. This is 10 volt battery, this is negative, this is positive. Okay, so we have to use here mesh analysis method. So again I think process is same. So let's, in this loop it is flowing I1. So again we will use here Kirchhoff voltage law, current law. Here again same I2, it was again same I3, because here will be three constants at 3 unknown. We can easily find through this. Okay, so question saying that find the current flowing through 2 ohm. Find current flowing from 2 ohm. Okay, so just applying in I1. So this is I1 and this is I2. So I1 minus I2 in second loop plus 2I2, just this 2I2 plus 6I1 because this is 2 ohm, this is 3 ohm, so 6I1, sorry, this is 6, this is 6I1 is equal to 10 because this is 10 volt battery. So this is first one. Now let's discuss with second. So 1, because here is nothing, here is given that it is 1, here was not any resistance mentioned. I2 minus I1 plus 2I2, I2 minus I1, this is I2, this is I1 minus 2I2, 2 means this is 2I2 plus 3 I2 minus I3, I2 is this I3, I2 minus I3, 3 because in this third loop So 3 ohm into I2, I2 minus I3. So this is equal to 0. Okay, let's solve it. So I2 minus I1 plus 2I2, this will be I2 plus 2I2, 3I2 plus 3I2, 6I2, right? 6I2, I1, this is I1, the minus I1 S dash minus I3, right? Minus I1 and minus 3I3 is equal to 0. Okay, so this is after solving this. Okay, so now what can we do is, again the third equation will be 3I3 minus I2 plus 10I3 plus 10I3, there is 10 resistance, so 10I3 is equal to minus 20. Now why this minus 20? Because I have missed something. Here's again one battery, sorry, here's some correction. This is battery of 20 volt. Okay, so this is battery of 20 volt. I hope you will understand. That's why here is minus 20. Why minus 20? Because it was finally going in this negative, that's why minus 20. So now what? Now again just solve it a little bit. 3I3 minus 3I2 plus 10I3 is equal to minus 20. So 13I3 minus 3I2 is equal to minus 20. So remember, this is third equation, this is second, and this is first. Let's solve it something. No, this cannot be I, this is one only. Okay, so I1 6I1 7I1 minus I2 2I2 plus I2 10 is equal to 10. Okay, so here is, we can also write it something. I2 is equal to 10 minus 7I1. Okay, 10 minus 7I1, and this we can write 10 minus 7I1, and this we can write so we can put here value of I2, and this will be term of I1, so why not we should put the value of I1. So there is something how we will put, simply we can three unknowns and three equations we can simply solve. We can simply solve. Okay, so if I am solving, then it will take a lot of time, which I do not want to waste. So let's discuss next topic, that will be, this has been done, that will be delta star delta conversion. Okay, so let's discuss about, so firstly we will also see in Google about what is mesh analysis and nodal analysis. What is mesh analysis mesh analysis and nodal analysis and nodal analysis. So in this, as we can see, mesh analysis, also known as loop analysis, which I told you that we can simply use KCL, KVL. So mostly we use KVL, Kirchhoff voltage law, to solve this current in planar circuit, while nodal analysis, also known as known voltage analysis, uses Kirchhoff current law. Okay, in junction. So here is some detailed explanation. Mesh analysis focus analyzing on analyzing circuit in terms of the mesh current, applies KVL suitable for advantages, can be efficient for the circuit with many voltage sources, works with impedances rather than admittances. Disadvantages also methods here, and this all. Okay, so now let's discuss about star delta conversion, delta star conversion. So now we will see delta to star conversion. So first of all, why we need this conversion delta to star? Sometimes the circuit becomes very complicated. We even can't solve by using simple series parallel method. So that's why we use it, and that is called delta to star method. Suppose we have delta. So suppose we have delta, this is resistance, this is resistance. So this is delta, kind of triangle, we say delta. This is RA, this is RB, this is RC. Here R means resistance. Okay, so now we want to change it in star. So simply we can do like this. This is star, so I can write it here. This is all. So we can say this is R1, R2 and R3. So basically we can also draw this separate, or in this, under this, I am just drawing under this so that it can be easy to explain. R1, R2 and this is R3. So need to remember that I will write some formula. So how will I write that? I will explain here. Suppose we have to find the value of R1. So remember this R1, we have to see that in which between R1 is, means what are the other side of R1. Suppose R1, we can see this is in between RA and RB, right? We can see this is in between RA and RB. So R1 is equal to RA into RB upon addition of everything. This will be RA plus RB plus RC. Got it? Now suppose we have to find R2. Then see here, R2, this is R2. Okay, this is R2. So this is in between RA and RC. So this will be RA into RC upon RA plus RB plus RC. This is R3. We have to find now R3. See here, this is R3. It is in between RB and RC. So RB into RC upon RA plus RB plus RC. Okay, So I hope you have understood what which I was trying to explain. Basically, simply we have given a delta, we will change it in star. So this is something how we will change. We will see R1, and in place of this, which type of resistance, how many resistance are there. So we will write something like this. So now let's do the question on it. Suppose we have question. Suppose example. What can be example? Same question, we can do that. So this is 1 ohm, this is 2 ohm, this is 3 ohm. So here, sorry, so here we have to find R1, R2, R3. So first of all we change it in resistance. This is R1, this is R2, this is R3. Okay, so R1 is equal to, this is in between, so RA into RB upon RA plus RB plus RC, R into RB, 1 plus 2 plus 3. Okay, so 3 upon 6, it will be equal to 1 by 2. Okay, so 2 into 1, it will be 2, so 1 by 3. Okay, and R2 is equal to, R2 means this in place of this R2, this is in between 1 ohm 3 ohm, so 1 into 3 upon same 1 plus 2 plus 3, this will be 3 by 6 is equal to 1 by 2. Same with R3 is in between 2 ohm and 3 ohm, so 2 into 6 upon 6, this will be 1 ohm. Okay, yeah. So this is something how we solve problems delta to star conversion. Now we will see star to delta conversion. Okay, star to delta conversion. So basically in this we will be given a star. So what is star? I have shown you that. Suppose there is R1, R2 and R3. So this star will be given. Now we have to change it in delta. So I can also make it separate, or I am just drawing in this. So sorry, this point will be here, this will be here, so that it can be complete. Okay, yeah. So this is RA, this is RB, this is RC. Okay, so here suppose we have to find RA, then again we have to check it that RA is connected from which two resistances. This is R1 and R3. So R1 plus R3 plus 2 R1 R3 upon 2 R1 R3 upon opposite side of resistance. So this is connected, opposite side is R2, so we will write here R2. Okay, same with RB. RB means this is connected from RB is connected from R1 R2. So R1 into R1 plus R2 plus, this is not 2, plus R1 into R2 upon opposite side of this. This is opposite side of it is 3. Here will be 3. Same with RC. RC is this. It is connected in between R3 and R2. So R3 plus R2, R3 plus R2 plus R3 into R2 upon opposite side of it is R1. Okay. So this is something how we find value of RA, RB and RC in star to delta conversion. Okay, now let's see the example. Suppose we have example. Suppose we have example 1 ohm, 2 ohm and 3 ohm. 1 ohm, 2 ohm and 3 ohm. So we will change it in delta. Okay, so this is RA, this is RB and this is RC. So first of all RA, so RA is connected in between these two, 1 ohm and 2 ohm. So 1 plus 2 plus 1 into 2 upon opposite side of it is 3. So this will be 3 plus 2 by 3. 3 plus 2 by 3. Okay, so 3 3 is a 9 plus 2 11 by 3 ohm. Okay, now RB is this. It is in between 1 ohm and 3 ohm. So 1 plus 3 plus 3 into 1 upon opposite side of it is 2. So 3 4. So this will be 4 plus 3 by 2. It will be 8 plus 3 11 by 2. Okay, RC is equal to, this is RC. RC is equal to, RC is connected from these two. So 2 into 3, 2 plus 3 plus 2 into 3, opposite side of it is 1. So 3 to 5 or 6 11 ohm. This is something how we find the value of RA, RB and RC in star to delta conversion. Okay, I hope you have understood whatever I was trying to explain. So now we will see superposition theorem. Superposition theorem. So what is superposition theorem? You all have studied in your 12th class or IIT preparation. We use it when two or more sources are applied. So first of all we can write it applies in a linear circuit. It applies in linear circuit. Or voltage or current in any sources but having more than one independent source. Okay, So let's discuss one example on it. It is 5 ohm, it is 1 ohm, it's 4 volt, and this is current downside 30 ampere. This is 20 volt. Okay, so simply we have to first of all short circuit. We will short circuit this one, then this one, and we will be able to find the current flowing through it. This is I flowing through this is I1, this is I2. So in I1, short the 4 volt battery, so this will be 20 volt as it is. $30 ampere, 5 ohm, 1 ohm. So we will apply here KVL. So we can simply apply here KVL, and then after we will short this one, then KCL, and we will be able to find I1, I2, then I is equal to I1 plus I2. Okay, so now we will discuss about there was something how we will solve, and we can also take another example. This is 3 volt battery, it is 6 ohm, it is 9 ohm, it was 2 ampere battery. So find the current, flowing through 9 ohm resistance. Okay, so what we will do, we will again sort this one. So I can write after sorting, it is simple. Okay, this is 6 ohm, 9 ohm, 3 volt, plus minus. Current is flowing in this direction. So if we have totalized it, then we can write it. Then we can simply do this. Not we are adding from resistance. So it is I1. So now again it is loop, or we can simply apply. This is I1. The I1 is flowing. So I1. Here we can see there's 2 resistances and 1 battery. So we can simply apply V is equal to IR and V upon, and we have to find I1. So I1 is equal to V upon R, and volt is 3, and resistance C, division series. sorry for disturbance. As you can see, it is in series, so simply add it. It is 15. 3 upon 15 I1 is equal to 3 upon 15 means 1 upon 5, 0.2 ampere. Okay, same with, we will find I2 for this short, 3 volt. After sorting 3 volt, what we will see, six ohm, 9 ohm, 2 ampere. So again we can see here is I2 current is given. We know that for this I2, if current is given, then we have to find first of all total current. We have this formula, total current into opposite side resistance upon total resistance. Okay, so for this what we will do, total opposite side resistance. So according to this, I2 is equal to total current means total current is 2 ampere into opposite side resistance. So this is 9 ohms, opposite side is 6 upon total resistance. Total resistance means 6 plus 9. So it is 12 upon 15. So 3 4s are 12, 3 5s are 15. So I2 is equal to 0.8 ampere. So from here we have found it I1, I2. So I is equal to I1 plus I2. This will be 0.2 plus 0.8. This will be I is equal to 1 ampere. Okay, so there was something how we find the value of I by using the simple sorting method. One more thing, that we use it to solve electric circuit. Okay, so now which topics are remaining? So here now we have to discuss Norton's theorem and Thevenin theorem. So I have some notes of Norton's theorem. So let me discuss about this. Although I can also discuss separately, but it will be easy to discuss in my notebook, and also it will save a lot of time. So that's why I decided to do this. So there is Norton theorem. Okay, so what Norton theorem says, first of all remember this: Norton theorem used in current source, Thevenin theorem used in voltage source. Okay, so this will be something circuit. There is battery, there is R1, R2 and R3. So steps, first is load resistance and load current. This is Norton current and Norton resistance, then parallel. There is something what I am trying to saying. So first of all we will change it in Norton current. So we will make something like this, and this will be Rn, means Norton resistance. We have to do this in parallel, Rn and In. So In is this, Rn is this. So this is second step. Third step is we have to let RL with IL. So IL is this. Simply for IL, formula is total current into opposite branch resistance and total resistance. So IL is equal to IN into Rn upon Rn plus RL. So main thing is to find Rn, because we face problem here. So what we do for this is step 1 to find IN. For this we remove RL. So after removing this will be simple circuit, and we can simply apply by Ohm's law, we can find it. And then simply we will short circuit it, then simply we will find it. Okay, so now we will see the comparison of AC and DC circuit. So we can see voltage change its polarity periodically. AC changes always. We know that in our home normal current comes to 20 volt and frequency is 50 hertz. You all know this. And DC remains same, do not change periodically. And this is energy loss less, and this energy loss is more. That's why we use AC circuit. It can be transmitted in long distance. Yeah, we also know that AC current can be transmitted in long distance. That's why we use it in our home. Mostly the AC current can travel more than kilometers or more than a miles, like 100 kilometers, 200 kilometers, and it takes very less loss of currents. While other side the DC current takes a lot of energy to transmit the light. We use generator a lot of time. If the length of wire which is connected in generator is very long, then the electricity which generator will be providing take a lot of consumption of fuels, and it will provide a less electricity. That's why we use AC circuit. AC, right? Okay, so it is, well, applying AC circuit, it is low cost, it is high cost. Some how DC is high cost. Suppose we are we want energy from generator, so we need to buy a fuel for this, that is around 100 or 90 rupees per liter. So it is automatically very expensive, and other side it is AC's current, so it is very cheap. Frequency is 50 hertz, frequency is 0. Okay, so now there are some important definitions. So waveform, what is waveform? The shape of the curve obtained by the instantaneous values of the alternating quantities along y-axis or time of single along x-axis is called the waveform. Okay, so these are some definitions, although I can also write it. Again, it will be waste of time, so I thought why not I should discuss, which I have already written. So that's why I'm doing this. So what is instantaneous values? Suppose what we do in instantaneous, suppose this is our curve, sine curve. So suppose we have to find the value here. So what we do, we integrate generally. So we integrate and we can easily find the value at any point of this curve. So that is instantaneous value. Suppose we have to find the value here. So that is instantaneous value, the value of an alternating quantity at any instant, called its instantaneous value. Okay, so what is cycle? One complete set of positive or negative alternating quantity is known as cycle. And this is your frequency. So number of cycles completed, this number of cycles completed by the alternating quantity in the 1 second is known as the frequency. Okay, what is phase? Two alternating quantity are called in phase when they obtain maximum or zero value at the same point. Okay, so these were some definitions. And that's all. Phasor representation, you all know that if we will be given something like this, so we will draw something like this, and sine component, this y-axis sine component, x-axis cos component, then simply we put it, simply we can find VRMS. Okay, so that's all about basic electronics. I have not as such any note right now. So thanks for watching. Thanks for watching. this side Raghavanshi.